Okay, so on page 58, so it tells us to solve the equation by using square roots. Square roots means that we have to have a quantity squared. So we want to rewrite this side so that it's a quantity squared. So based on what we did in the warm-ups, what's another name for this? What's it going to be, Joey? Another name for x squared plus 4x plus 4. What was that? Right, so this is going to be x plus 2 squared equals 2. And now it's a problem just like what we did in the homework. So we're just going to take the square root of both sides. And we have x plus 2 equals plus or minus radical 2. We're going to subtract 2. These are not like terms. So it's just going to be negative 2 plus or minus radical 2. That's going to be our solution. Okay. And here's what the rule is, guys. If I want to see if this is a perfect square trinomial, I have to look at this middle term. If C is equal to 1/2 of B squared, then it's going to be x plus or minus the square root of C quantity squared. Let me show you what I mean by that. So I'm going to look at this. Here's my B term. I'm going to take half of it. Half of it's 20. I take half of it, then I square it. 20 squared is going to be 400. So because my C value right here is equal to 1/2 B quantity squared, then I know then that I can actually just rewrite it like this. It's going to be plus if this is a plus. It's going to be minus if this is a minus. So therefore, this is going to factor down into t minus, and then I do the square root of C squared. That's how we can quickly factor it. And so now I take the square root of both sides to solve. So I'm going to have t minus 20 equals plus or minus radical 300. And then we just have to add the 20. And you should always keep that real part first and that imaginary part. And how can that simplify down, Drew? This is going to be simplified. 100 times 3. So it's going to be 10 radical 3. So the answer should be 20 plus or minus 10 radical 3. This one we just did in our warm-up. It's the exact same problem, but I haven't factored this for you. So we're going to try to factor this. So we're going to set up our double parentheses. Maybe we don't realize that that is a perfect square trinomial. So to find out if it's going to be, then we're going to have to put 3w and 3w, and then 1 and 1. We're trying to get a 6w with the outers and inners, so it's going to be a plus and a plus. And now it just turns into that same problem that we did in the warm-ups. Okay? And back here I want to say this. So given x squared plus bx plus c, this can actually be plus or minus. So these rules hold true for this. When we're given this function, if c is equal to 1/2 of b squared, then it's going to factor down into x, plus if it's a plus, minus if it's a minus, the square root of c squared, quantity squared. Alright, so in this, we're just trying to find the value of c that's going to make this a perfect square trinomial. So we're going to look at our b value. What do we do to it first, Sydney? What we say we're going to do to it up here to find c. Yep, so we're going to divide it by 2. What's that give you? So we have to do 7, and then we have to square it. And so what's the c value going to be then? Sydney? Well, c itself is going to be 49. We have to square 7. So we did half of 14 with 7. 7 squared is 49. And so now to come up with the way it's going to factor, it's going to be y, this sign. Here's my c value, 49. So I would have to do the square root of 49 which is 7 squared. 5 we will do together in just a minute. I want you guys to do 6 now on your own. Figure out what C is and then factor it. Tyler, what did you get for C?
144.
Good. So then our problem is Z squared plus 24Z plus 144. And then how did you get it to factor? Good. Okay. Let's look at number 5 now together. Number 5 is difficult because we have an odd number here for B. But it's still the same process. We're going to do B divided by 2, and then we're going to square it. We are never going to use decimals in this process. I'm not going to call that 8.5 squared, because I can't even do 8.5 squared without a calculator. It's not something we can do in our head. But this I can do. It's going to be S squared plus 17S. That C value is going to have to be 17 squared, which is 289, and 2 squared, which is 4. See, now we can take the half of it and square it and get a nice number. So now the way this is going to factor, it's going to be the square root of that, which is S, this sign, and the square root of that is 17 halves squared. So do you understand how to find C now? Okay, so we're going to be using that to solve problems, equations, by completing the square. So looking at number 7. The first thing we want to do is we want to get this 2 out of the way. So we're going to add 2. So we're going to have r squared minus 6r. Leave some space right here, because we're going to complete the square. So we're trying to figure out what is the C value that we can add to make this a quantity squared. What's it going to be, Charlie? Good. How did you get that? Good. So guys, here's the thing though. I have to keep the equation equal to what it was at the beginning. At the beginning, I had r squared minus 6r equals 2. I added 9 to this side. So to keep my equation balanced, I have to add 9 to this side. So now can you see how if I subtracted 9 from both sides, I'd go back to that same equation I started with? So this is equivalent. I'm allowed to write that. I can always take an equation, I can add to both sides, I can divide both sides, I can multiply both sides, and it stays equivalent. Therese, how is this left side going to factor now? Good. So r minus 3 quantity squared is 11. And now we're back to last night's homework. We solved this by taking the square root of both sides. And we're going to get r minus 3 equals plus or minus radical 11. And so r is going to be, bring the 3 over, positive 3 plus or minus radical 11. Okay, number 8 is just the same, so we're not going to do that one. We are going to do number 9 because it has a little bit of a different twist to it. Here's something, a mistake I always see people make. They're like, oh, this is already factored, so y has to be 3/4, so y plus 1 has to be 3/4. You cannot do that. The only time we can do that is if this is factored and it's equal to what? 0, yes. If it's equal to 3/4, we cannot say that one of those has to be 3/4. That's not true. So what we have to do here is we have to distribute the y through. So we have y squared plus y equals 3/4. So the only way to factor this or to solve this is to complete the square. What's the b value in this case going to be? Natalia, what's the b value in this case? It's 1. So if I take half of 1, I get 1/2, and if we square it, what are we going to put? What are we going to add to both sides? Natalia? So I'm going to add 1/4 here, and I'm going to add 1/4 here. Now, remember how this factors? This is going to go down to a quantity squared. Dominic, do you know what quantity is going to go inside of there? It's going to be the square root of this, which is y. It's going to be this sign. And what's the square root of 1/4, Dominic? No, you guys, 1/2, right. So we get equals 1/2, and then 3/4 plus 1/4 is going to be 1. So now our next thing to solve this is just to take the square root of both sides. So we're going to have y plus 1/2 equals plus or minus, square root of 1 is just 1. And so now we're going to have to subtract 1/2 from both sides. So then y is going to equal 1 minus 1/2, that's just 1/2. Negative 1 minus 1/2 is negative 1 1/2, or negative 3/2. Questions? All right. So, let's take a look at number 11. This will be the last one of this type we do. Oh, Maya? Well, we do have two answers on the other one. One of our answers is 3 plus radical 11. The other answer is 3 minus radical 11. So that's two answers for that. Yeah, that's fine. Okay, so you're talking about an improper fraction?
Yes.
So should you leave it like this? I don't care. If it's not specified, if I don't say one way or the other, you can have it. You could have negative 1.5, unless it said no decimals. So, yeah. Any other questions from so far? See how we're getting two answers each time. This is 3 plus, radical 11 is about 3.2. So this is really 3 plus about 3.2 and 3 minus that. Okay, so two answers. All right, now let's come down to number 11. Charlie Plummer, can you tell me what we would have to do first? Yeah, so we're going to have to get 6x squared plus 30x equals negative 24. In order to use this process of completing the square, the coefficient in front of x squared must be a 1. If it's not a 1, you cannot complete the square. So what can I do to make it so that we have a 1? Ms. Sonia? Good. I'm going to divide every term by 6. And now we're going to complete the square. And this one's going to be a little more difficult because anytime we have an odd b value, it's a little bit harder to complete the square. So Becky, if I take half of 5, I'm not going to write it as 2.5, I'm just going to think of it as 5 over 2. What do we get if we square that? Nope. Well, I want you to do it just like this. To square it, you're going to square the 5 and square the 2. What do you get? Good. So I have to add 25/4 there, and I have to add 25/4 there. So we don't want to write it as a decimal. We do want to keep it as an improper fraction. Mitchell, do you know how this is going to factor here? It's a little bit tougher, but it's always x plus and then this square root. Right, so it's x plus 5 over 2 squared equals. Now I need to combine these. Okay, well, what am I going to have to do if I'm going to combine those? Well, I have to have a common denominator, right? So I'm going to multiply this one by 4 over 4. So that's going to be negative 16 over 4 plus 25 over 4 in order to combine those two. So that's going to give me 9 over 4. So even though we have these fractions, it's no big deal. We can still solve those. So to solve that, we're just going to have to take the square root of both sides. So we take the square root here, we take the square root here. Let's just ignore this. We're not doing that problem, so we'll just use this space. So now we're going to have x plus 5 halves equals what, you guys, everybody? Right, so positive or negative 3 over 2. And so then to finish, we're going to have to subtract 5 over 2. And we should always get 2 answers. Every time we should be getting 2 answers. So now we're going to have positive 3 halves minus 5 halves. That's negative 2 halves. And negative 3 halves minus 5 halves. That's negative 8 halves. So I have negative 1 and negative 4. When we get nice answers like that, that means that it could have been just factored at the very beginning. Right here, can you see how if I brought that 4 over, I could have factored that? Let me just come over here. If I had just brought that 4 over, I would have had x squared plus 5x plus 4 equals 0. Look at that. How does that factor? Jake, how's that factor? Right there. Good. And see how my solutions would have been negative 1 and negative 4? So guys, you're not going to be told away you have to do a problem. In fact, on this problem, I'm hoping you would notice right here, hey, it'd be a lot easier if I would just bring that 4 over and factor it. Okay? But I just wanted to show you how, on some problems, there's no other way but to just go through it like that. Okay? I want you to read this next one. This one's kind of tricky, and this is something that is not really going to be something you'll be assessed over, but it's just kind of interesting. It says, explain how this expression is a perfect square trinomial. Then write the expression as a square of a binomial. A perfect square trinomial means that it has to meet that requirement where if I do b over 2, here's my b, 8 divided by 2 is 4, squared is 16. So that's how we know it is a perfect square trinomial. That's the explanation. Write the expression as a square of a binomial. Guys, we're really thinking of this as x squared plus 8x plus 16. See how 4p plus 1 can just be thought of as an x? Okay? How would I factor x squared plus 8x plus 16? Elena, do you know how that would factor? X squared plus 8x plus 16? It would be 4 and 4, wouldn't it? So it would be x plus 4 squared is how that would factor. But what is our x, you guys? It's not really just an x. What is it? Right, so it's 4p plus 1. That's what the x is, plus 4 quantity squared. And so this is going to be 4p plus 5 quantity squared. Now last period, I had them work in groups on this, and I was hoping they would see this shortcut, but nobody saw it. What do you think they did? They got the right answer, but what do you think they might have done? Yeah, Natalia? Well, that's one thing, but they didn't try to solve for p. They actually multiplied it all out. Like they did 4p plus 1 times 4p plus 1. They distributed this. They combined all their like terms, and then they factored it. That's a good way to do it, but it's a pretty difficult way. This way is much faster. Okay? Let's look at the back. Or on the next page, rather. This is page 59. It says, in exercises 14 through 17, determine whether you would use factoring, square roots, or completing the square to solve the equation. Explain your reasoning. Then solve the equation. And Lisha, how would you solve this first problem? That's great. So I would do the same thing, and that's because it's set equal to 0. If it's set equal to 0, we want to try factoring first. So I can factor that just by factoring out an x. then we're left with x plus 7. And then we can very simply solve this. We get x equals 0, and we get x equals negative 7. Two solutions. Was anybody thinking of a different way to solve it? Okay, good. Some people in my other class did this by completing the square. Yeah, they got the right answer, but it took a lot longer. So we want to try to think of the easiest way. As we go through Honors Algebra 2, quizzes and tests get more difficult, and time becomes a factor. So you want to do things in the quickest way. Go ahead and try 15 on your own. Think of the quickest way to do it. Caroline, what'd you do? Not done yet? What are you starting to do? Yep, perfect. So I'm going to work along with you. So in this one, we can take the square root of both sides. So we're going to get x minus 1, positive or negative, radical 35, and then we can just add 1. This is the best way to write the answer. How many answers would that be? 2 answers, yes. Okay, what about 16? Take a look at it. Think about the easiest way to do it. Charlie Hall, what do you think?
Just add the 25 to the opposite side.
Good. Perfect. I agree. That's the fastest way to do that. What about number 17, Drew? What would you do first before you even try to do anything? Okay, you don't even have to factor out a 4. Because it's an equation, you're allowed to actually divide by 4. As long as it's an equation. If it hadn't been an equation, you would need to factor it out. But if it's an equation, I can just divide every term by 4. So now I might want to check this to see if it's factorable. Are there numbers that multiply to be 3 and add to be 2? No, there's not, are there? If this had been a subtraction here, I could have factored it, but if it's a plus, I can't factor it. So what's probably our best option then? Maya, what do you think we should do if we can't do it that way? Okay, actually subtract 3. Okay, and then we have to take half of this and square it. What do you get, Maya, if you take half and square? 1, so we're going to add 1 to both sides. And what's another name for this now, Maya? X plus what? 1 or 1/2? 1. Square root of 1 is 1. Squared. Negative 3 plus 1 is negative 2. Okay, I'll let you off the hook then. And Sydney, what do I do now? Take the... So now I'm going to have x plus 1 equals plus or minus I radical 2. To finish the problem, I have to subtract 1. Those are not like terms, so it's negative 1 plus or minus I radical 2. Two solutions. How many x-intercepts? If this function had been this equals f of x, how many x-intercepts would there be? 0. Why, Baxter? Right. This is 2 imaginary solutions, so therefore that it would not have any x-intercepts. Okay, let's look at the next one now. The area of the triangle is 30. Find the value of x. What are you thinking we could do? Anybody know anything that could be helpful? True?
You could do 1/2 of 3x times.
Okay, so you're saying we should do 1/2 base times height. What does that have to equal then? 30, right. At this point, I would get rid of the 1/2. Okay, this is all multiplication. So to do that, I would just multiply both sides by 2. Now the 1/2's gone. So now I have 3x times x plus 2 equals 60. Can I just set 3x equal to 60 and x plus 2 equal to 60? No way. That's not going to work. So, Becky, what do I have to do instead? Yeah, I have to distribute it out. So I'm going to get 3x squared plus 6x equals 60. Harish, what should we do now? Yep. X squared plus 2x equals 30. Thank you, 20. Okay, so now I'm going to think, could this be factored? If I took it over here, would there be numbers that multiply to be 20 and subtract to be 2? Factors of 20 are 5 and 4, 2 and 10. It's not going to work, is it? So I'm going to have to just complete the square. It's my only other option. Jake, what am I going to add to both sides? So I'm going to add 1 here, add 1 here. Jake, how does that factor then? Take the square root of both sides. So then x plus 1 equals plus or minus radical 21. X is equal to negative 1 plus or minus radical 21. We have 2 solutions, but I'll tell you, it says find the value of x, not values. So only one of these can actually be a solution. Which one is the solution going to be, Michaela? Why is that? Right. So 2 negatives would have to make a negative, but this is actually about 4.5, so negative 1 plus 4.5, that's about 3.5, that's fine. Okay. Next one. Guys, this is a very important problem, and you only have one of these in your homework, but I'll tell you, it will come up again, so make sure you can do it. It says, write the quadratic function in vertex form. Here's vertex form. Y equals x minus h squared plus k. That's the kind of form we're trying to get this into. So in order to get this x minus h quantity squared, we have to complete the square. But it's done a little differently here. We have f of x equals x squared plus 6x. Plus 22, though, is not helping us, so I'm just going to move it over, kind of out of the way. I want this part right here to be something that's going to turn into x minus or x plus h. So what am I going to have to add? What am I going to put here, guys, to make this into a perfect square trinomial? Take half of 6 and square it. 9. But if I added 9, I still have to keep the equation balanced. I've got to keep it equal to what it was in the beginning. So since this 9 is on the same side as what I'm going to put here, do I want to put plus 9 or do I want to put minus 9? Minus 9. That's going to keep it equal, isn't it? Because if I have a 9 minus 9, isn't that going to still just be, see what I mean? That's still going to be the same thing as it was at the beginning, because 9 minus 9 is going to be 0. So now we can rewrite this. How does this get rewritten right here? What's that going to be? Natalia, how does that factor right there? Right? Good. Plus 13. So there's going to be our equation. And so now we should be able to know what our vertex is. Mitchell, what's our vertex going to be? Good. Guys, this is even something that I could check. You have your calculator handy, get it out. So I'm going to go to my y equals. I'm going to put in that original function, which was x squared, let me clear this up, x squared plus 6x plus 22. So we're going to put in that original function, and we want to be able to see the graph of it, so I may need to change the window. If I just do a zoom 6, what's that vertex supposed to be at? Negative 3, 13. So I got to make this window much higher. I'll make the y max 30. So now here's the way my graph looks. Now I can see that vertex. I have a couple of things I can do. I can look at my table, and I can see if those points are on there. Adjust my table. So I'm looking for the point. That is weird. Something has happened to this calculator. Let's see something. Okay, we're going to do another thing then. For some reason this isn't giving me a nice table. I'll figure that out later. Okay, so what we're going to do is this. Second trace, we're trying to find the minimum. Do you see how the minimum of that function is going to be the same thing as the vertex? So I have to go to the left of it, hit enter. To the right of it, hit enter one more time, and it's going to tell me right there at negative 313, that's the vertex. So that's a way we can check it. Questions on that? Alright, let's go to the last problem. It says the golfer hits a golf ball on the fairway with an initial velocity of 80 feet per second. The height in feet of the golf ball t seconds after it is hit can be modeled by the function h of t equals negative 16 t squared plus 80t plus 0.1. Find the maximum height of the golf ball. Okay, can you tell me what kind of shape this is going to be and which way it's going to open? Charlie Hall, do you know? What kind of shape is it? It's a parabola, right? Which way is it going to open? It's going to open down. So they ask us to find the maximum height of the golf ball. So I want you to think about that. How are we going to find the maximum height? Does anybody have any ideas? What do you think, Tyler? Good. So if we find the vertex, we can find that maximum height, can't we? How are you going to find the vertex, Tyler? So negative 80 over negative 32. Grab my calculator to do that. 80 divided by 32 is 2.5. So I know that my vertex then is 2.5. What do I do now, Tyler? Okay. I'm going to come over here, and I'm going to have to do negative 16 times 2.5 squared plus 80 times 2.5 plus 0.1. And I get 100.1. Okay, so there's the vertex. The question is asking me to find the maximum height of the golf ball. How many people say it's 2.5? Good. How many people say it's 100.1? Good. Yes, that's correct. The y value is going to tell us the height, isn't it? So it's going to be 100.1 feet. Then it says, how long does the ball take to hit the ground? Anybody know what to do for that? Yeah, what do you think, Natalia? Okay, how do we find the x-intercepts? Oh, okay. I think that's a little tougher, though, than it seems to be at first. We would have to factor that to get it into that x minus p and x minus q form, and it's not really very factorable. But that's a great idea. Guys, the only way we can do that, she's right. The key is that the height has to be 0, right? Isn't that the height when it hits the ground, 0? So I have to know when is it that this equals 0. I could solve this in many ways. I could complete the square, but I've got to divide everything by -16. I could try to factor it, but it can't be factored. I think our best shot here is to do this on the calculator, because all those ways are going to be pretty difficult, and we want to do things the easiest way. So I'm going to put this in under y equals, and I'm going to do a zoom 6, and I may or may not see it. Now most of it I'm seeing, but I'm not seeing the vertex. I'd like to see that. I'm going to change my window. I got to make it go up higher, maybe 100. Let's see what happens there. If I can see the whole thing. Yeah, that's pretty good. The path of that golf ball, that's not a great path, going up so high like that. So we're trying to find out when it hits the ground. So I'm trying to find out this point right here when y is 0. See, there it is going up, up, up. Now it comes down, and it's going to land right there. How long does it take for it to hit the ground? Okay, does anybody know what we're going to do? How can I find that out? What do you think, Sydney? Yeah, good job. So I'm going to go to y equals. I'm going to go down to y2, and I'm going to let it equal 0. And now I want to do, on my graph, I want to do second trace, and I want to calculate that point of intersection, because I want to know when is it 0. Now it tells me way over here what it is. I don't want to know that one. I want to know after it's been in the ground. And by the way, this isn't really the path of the golf ball. This is comparing the time to the height, so it's really not a bad shot. So we get 5. To the nearest hundredth, 5.00, so we're going to say then that it's going to take it 5 seconds to hit the ground. Okay, any questions there? All right, good job. So we'll go over the homework now. So go ahead and get that out.